So the other day we did a really deep dive into the injection side of the molding machine, and specifically we talked an awful lot about the nozzle tip. I wanted to go a little further downstream and talk about the sprue bushing and how the nozzle engages into the mold. So to that end, let's pull a sprue bushing out of the mold and take a look at it. So once it's out, this is what your sprue bushing looks like. And of course, this is where the nozzle of the machine interfaces to the mold. And if I show a runner and sprue, this is the actual plastic bit, in conjunction to the sprue bushing, you can kind of see how this works. So the sprue bushing holds the sprue, it gets injected deep into the mold, and then when it opens up, you extract the sprue. There's one other interesting thing that we haven't talked about very much at all and is super relevant. So some people will look at the sprue and they'll think, well, that's an awful lot of wasted material, especially if your part is not very big. And you know, there's an argument to that. We do grind these up and we reuse them in different parts, but nevertheless, that is an amount of energy that we have to put into dealing with these things. So this sprue is a little bit longer than the other one I just showed you, but it functions the same way. The nozzle comes in contact with it, and this is where you interface into the mold. However, in this case, this entire sprue remains a liquid as you're processing the parts. So unlike a cold sprue, this allows the material to remain in the sprue, and what is not used in this shot gets used for the next part. And it just continues on every cycle. Now you might have actually seen the result of something like this. They're kind of common in products like this, for example. So if you look right here, you will see the impression of a hot sprue. And it's pretty interesting because our diameter for a sprue in the US is typically 1 inch. So if we look at this ring and we line that up, lo and behold, it's exactly 1 inch. So in this mold, you have one hot sprue here and you have another one over here. So each time this thing gets made, there is no sprue to discard. Kind of cool. There are definitely pros to that. There's a lot less material that you have to use for your production, and you don't actually have to deal with the sprues or runner after you shoot the part. Now your hot sprue is not a silver bullet. It does not solve all problems. It comes with some negatives as well. So there is a thing called resonance time, and that is the amount of time it takes for the material to come out of the hopper into the barrel and then finally end up in your mold. And if you add a hot sprue to this, you do actually lengthen the time. Also, if you're trying to get really precise parts, if you're trying to hold plus or minus 2 thousandths, there really is no substitute for a cold gate right into the part. That will give you the best accuracy and ability to hold tolerances. But of course the downside is you end up with a sprue you have to throw away. So, you know, pros and cons. Now here's another problem. Different hot sprues operate with different equipment. So you can have something like this, you can have something like this, you can have a plug like this, or you can have a plug like this. See, your hot sprues will come in all kinds of different shapes and sizes. They'll also come in different kinds of interfaces. So this one happens to be 120 volts and is controlled by a PCS temperature controller. However, this one over here is 230 volts and is controlled by a UDO temperature controller. These are not interchangeable, not even close to interchangeable. This one over here, this is 230 volt, but it's controlled by a DME temperature controller. Again, not interchangeable. Now it is kind of cool that these come with your heater cartridge and your thermocouple built in. But some of these use a J type of thermocouple and some of these use a K type of thermocouple. So it depends on the material you're running. You might be into the higher temperature ranges, and not all thermocouples are optimized for that temperature range. So between your interface types, your plugs, your temperature controllers, and your thermocouples, there's a lot of variety. Now another consideration is price. So your standard sprue bushing might cost you a couple $100. So for a hot sprue, you might be looking at, $900 and above. Now that doesn't sound like a tremendous amount of money when you're looking at a mold, but realize that if you've got multiples, things start adding up. The bottom line is it's a fairly complex system, and the part design itself will kind of tell you what the right answer is, whether you should have a hot sprue or a cold sprue or a hot gate or a cold gate. That's sort of dictated by your budget and ultimately the shape of your part. Well, that's all I've got for you today. But make sure you come back and check out the channel later because we're working on some really cool things. Don't forget to like and subscribe so you can get all our latest content. And remember, go out there and do something cool today.